Okay, in this video, we are going to revisit a project that I did a while back using LoRa radios in a long-distance remote control application. So I had two LoRa radio modules, which you can see on my breadboard. Each one was connected up to a SCAMP board, which was running a PIC microcontroller. One was set up as a transmitter, and another one was set up as a receiver. And I was sending ASCII character codes over the LoRa link to turn on 4 LEDs, which could be 4 relays. Now the transmitter was hooked up to my keyboard, so it wasn't portable. So in this video, I want to make the transmitter portable. So what I'm going to do, I'm going to hook up my transmitter up to a flipper device. This is a Flipper Zero. It's a little handheld device. It's battery operated. It's got a SD card. It's got a USB port. And inside is the STM32 ARM microcontroller. And it has a GPIO output on the top. And I made a little board, interface board, which you can see here, with a LoRa radio module, and it plugs into the top of the flipper board. So now it's portable. Now I can send data from the flipper board over to my receiver instead of having my keyboard running the show. Now I have my transmitter hooked up to my keyboard, my computer, and every time I hit a key on the keyboard, it's going to send that ASCII character code. You can see here, you can hear it. I have a radio on. So I have the 4 LEDs mapped to the 4 keys A, S, D, F. So capital A, capital S, capital D, capital F will turn on the 4 LEDs, and lowercase a, S, D, F will turn off the LEDs, which could be relays. So if I go caps lock, so now it's capital, so if I hit the letter A, that's ASCII 65, it'll turn on the first LED. S is ASCII 83. D is 68, and F is 70. You can see all LEDs are on. If I take the caps off, then this is lowercase, and I will turn them off. A, S, D, F. Okay, I have my LoRa interface board plugged into my Flipper Zero, and I have an app running called UART Terminal. And right now I could select capital A. You can see capital A in the text box. Now if I go over to save, now when I hit the center button, it's going to send that command. You heard it. I could send it again. So that would turn on the LED or relay. Now to turn it off, send a lowercase a. Do the same thing. Bring it over to save. Now when I hit the center button, that would turn off the relay or the LED. Okay, I built my LoRa interface board using a SCAMP3 protoboard. And I'm using it as my development board also. I have 2 LEDs. This is my 5 volt LED. This is my 3.3 volt LED, so I could tell if I have those 2 voltages on the board. Then I could select what voltage I want to feed my LoRa module by this jumper here. If it's jumper to the left, that's 5 volts. If it's jumper on the right, that's 3.3 volts. I have a dip switch. When it's up, that means it's in transmit mode. And when it's down, it's in program mode. And I have a socket for the LoRa radio module, so I could plug in different modules. And this is a 20 dBm module. It puts out 20 dBm, so we get a range of about 3 kilometers or 2 miles. If I want more range, I could plug in this module here. This is a E32. This is a 30 dBm module, 8 kilometers or 5 miles. Or I could go to a sped spectrum radio, frequency hopping. This is the E34 module. I could plug that in. It's 2.4 gigahertz, and it puts out 27 dBm. Which should have a range of about 5 kilometers or 3 miles. So it's pretty versatile. It's my development board, and it just plugs into my flipper. Now on the flipper, we have 5 volts and 3.3 volts available. Then we have GPIO pins, and we have the TX and RX, the UART. So that plugs in into the top of the flipper. And now I have control over my interface board. Okay, with my interface board plugged into my flipper, whenever I turn the flipper on, it's always going to give me 3.3 volts from the flipper battery. Now to get 5 volts, if I plug in my USB port, my USB connector into the side of the flipper, you can see that my 5 volts comes on. If I unplug my USB port, the 5 volts goes away. So we're getting our 5 volts directly from the USB port. Now if we want to go totally remote and portable, so without a connection into the USB port, I could actually turn on the 5 volts with the internal battery. So I go to GPIO and I select 5 volts on, and it turns it on. So now I have the converter inside the flipper is giving me 5 volts from the battery, and I could turn it off and I could turn it on. I have control now of the 5 volts. So either I could get it from the USB port or I could get it from the battery. Okay, I could also program my LoRa radio module using my setup, using my flipper. If I put my dip switches down in the down position and I go to GPIO and I select USB to UART bridge. So this is now a USB to serial converter. Now I could run configuration software from eByte and I could program my LoRa radio module. Okay, I have my eByte configuration software up and running on my computer. It's RF setting. And I have my USB cable plugged into my flipper, and I'm using my flipper as a USB to serial bridge. So if I select English and open the port and get parameters, so it's got the parameters and there they are. So now we can configure the UART baud rate. I have that set to 115.2K baud. Parity is 8N1. Over the air data rate is 1200 baud. Power output is 20 dBm. And my channel is 15 and my address is 0. So I select set parameters, and now we program the LoRa radio module using the flipper board. Now in a normal remote control application, you usually have visual sight of the device that you're controlling and you get visual feedback. But if you're in a long distance, say a mile away, and you send, say, a character, a code to turn on or off the relay, you send it. Now this screen here is the receive screen. So you could have the receiver send back an ACK saying relay on or relay off, and it will come on as text in this box. So this is your receive box from the UART. Now the Flipper Zero is also a piece of test equipment. You can use it for testing a lot of devices. It has a sub-gigahertz radio receiver. So if we go into the menu and we go to read raw, and now I got my key fob of my car, and it's reading the data. So I could stop it, I could save it, and I could replay it if I want. Now I could also read my garage door opener. So if we go into read raw and I hit record, so there it is there. Every time I press it, it's reading the data bursts. So now I could stop it. Now I could save it, or I could actually send that data. So this will actually transmit that data. Now I could also pair my flipper to my garage door opener. If I press the pair button on the back of my garage door opener, I could use this to pair it, and then this would become my garage door opener. Okay, other features of the flipper is RFID reading. So it'll read RFID tags. Also, if you have an embedded microchip in your pet, in your dog or cat, it'll read that. We have near field communication, so we could read debit and credit cards. And there's also infrared. Right here, transmitter receiver. So if you have a remote, you could learn the remote and you could use the flipper as your remote. Okay, so that was a little tutorial how you could use the Flipper Zero in a remote control application. And the schematic of my protoboard is pretty simple. You can see all you need is a power supply, either 5 volts or 3.3 volts, and then just a TX and RX of the UART feeding the LoRa radio module. So I hope this video gives you some ideas, if you own a flipper, how you could build a little protoboard for development applications.